Hi everybody, my name is Nathan Stevens, and here is my presentation for my final project for advanced gameplay programming. So I decided for this final project to make a game that I called Riot, and this is actually based off of my week 3 project called Classy Classes, and the main functionality of that was to use object pooling. So I took that and expanded it into this current game. So let's do a playthrough, and then after the playthrough we will look through and see exactly the features that I added to it. I lost at the very end. Let me try again. Yeah, this game is really challenging, which is exactly how I wanted it to be. So let's do this one more time. Okay, I won. That was pretty close. And in the actual build, when you press quit, it would actually quit out of the application, but I'm pretty sure in game mode in the editor it won't end the game. Okay, so if we look right here at the final project, we're gonna look at these 5 things that we definitely need, and then we have 4 topics that are also required, and I also did some more for extra credit. So let's go through these one by one. So first off is namespaces. So for namespaces, I actually used those for all of the fading, and that was also coroutines actually. So if we go to the very bottom, I believe, oh, here it is in the splash sequence. So I used a namespace called fade library, and as you can see within the fade library they're using coroutines, which is the second one that I need to use actually. But anyways, as you can see I named it fade library, and then I used a fade class, and I have an enumerator called fade in and an enumerator called fade out. And what these do is that it takes the canvas group of the game object, which pretty much controls the transparency, and for fade in it will decrease it by, or not, it'll actually increase it by 0.005 every single 0.01 seconds. And for fade out it's the exact opposite, where every 0.01 seconds it'll decrease the alpha by negative 0.005. And we're able to utilize the fade library namespace. As you can see right up here we say using fade library, and in the class we have to instantiate it, so we say private fade, and it wouldn't really work until we instantiated it right here, so we create a new fade, and then finally here we're able to say coroutine equals fade.fadeIn, and what we're doing is we're passing the object that we either want to fade in or fade out. So this way it's a pretty dynamic function. And one way that we could make it even more dynamic was to also include a parameter for timing, but I did not include that because this was a one-time use. So we covered step 1 and step 2, so now for the third required concept is an interface. So if we go to the, I believe it's for the sound is what I did. Let me look really quickly. It is actually, if I go to the scripts, one moment. Countdown script. Right here. Okay, so we use an interface called IEmitSound. And what this does is that whichever class uses it, it's going to end up using a function called outputSound. And as you can see, there's a lot of sound in the playthrough, if you recall, but we're especially going to use this for whenever the user clicks one of the squares, because we want to have a clicking sound. We pretty much always want to have instant feedback that really adds immersion. So what I do is I have the interface IEmitSound, and it has a parameter called sound, which is a game object in the method, and within the class event script, it implements the IEmitSound interface right here, IEmitSound. In this way, it's going to be using the output sound from this interface. So when we press play, we can see that as the loading screen starts, it's going to show the logo and the name, and then it's going to fade out, and this is calling the coroutines, the fade library from the namespace. Then we click start, and as you can see, you can hear the clicking. So that is implementing the interface IEmitSound. Now for getters and setters, these are also property attributes. So let's go to our object pool manager. And as you can see, we have the player class right here. And the player class tracks the lives and the score and whether the game is over or not. So obviously the game will not be over to start, so we set it to false. And then we also have lives and score. So at the very bottom, under start, we want to set the score to 0 and the lives to 3. So what we're doing here is this is pretty much masking, and it's using private variables. So for over, it's pretty straightforward, just get and set, those are standard. But for lives, what we do is we want to check, well, first we want to update the lives text. So if you noticed in the upper right hand corner, it shows the number of lives left and the score, and that always updates as the game plays. And usually if you want to constantly update something, you would think to put it in the update function, but that's very inefficient because that's going to be running every single frame, and we only really want to update the text when the value changes. So the logical place to put it would be in the set property itself. So we set it and convert it to a string, so that way it outputs as text. And then we have a if statement saying that if the lives equals 0, meaning if the game ends, then we just set over to true, and then we're going to set the end text to sorry you lost, which I'm afraid a lot of people are going to see because this game is really hard. And it's sort of the same thing with score. It's the same logic where we have to output the score with the new updated integer, and then we check if score equals 30, which means that they won. Then we set over to true, and we say that the end text is congratulations, you win. And whenever we are setting anything within the properties, we always want to change the private variables. So that's the getters and the setters. And actually, just to show it in the event script, we are editing the lives and the score right here. And notice that we're not calling the private ones, we're calling the public ones. And finally, scriptable object. So the scriptable object that we're using is actually for size delta. So as you see, assets, create, red Riot, create custom size delta. So right here under under resources, size, here is it right here, the width and the height. But let me just delete this. Let's just do it from scratch. So create, red Riot, custom asset, and right now our default square is 100 by 100. So where is it? Right here. If we click right here, you see that this is sort of the prefab, and it's 100 by 100 for width and height. So this is sort of proving that when we change just one setting, that it will change, that it's working, that it's changing the width and the height, which is also referred to as size delta. So let's change it to 105 by 105. We need to put it in the object pool. So now, let's save that. And when we press play, let me minimize it. And this way we can see that the width and the height are all 105. Whereas right here, the original one, it's still 100. So this is proving that every single object in the object pool is taking its size delta from this custom asset. So let's take a look of exactly how that works. So what we do, if we go back to our object pool manager, is that we have a class called custom size delta, and it's just one line. We really can't get any simpler. We have public float, width, and height. And like I said, size delta is just another name. It's when you use the rect transform class for UI objects. And as you can see right here, we have file name custom size delta, which is the name, as you can see right here, custom size delta. And then we have a menu name, red riot create custom size delta. And then order equals 1 means that this is going to be at the very top. So red riot is create red riot, and then create custom size delta. So that's how we created our menu. And in order to use our menu, and also we made it a scriptable object right here. So in order to actually use it, what we do is we say public custom size delta template, and we're actually creating a template, and we're loading it from a resource as custom size delta. And what we do is we take each object and we take its size delta, which is a variable of the rect transform component, and we make a new vector 2 of width and height, but we're taking the width and height from the template. And as you can see, this is actually a custom method, and load from resources is called at the very bottom when we're creating the pool. So as you can see, we are creating a new game object called temp. We're instantiating it, and pretty much after we set the random color and the random position, we call the load from resources, and this is the path that the asset custom size delta is located. And then we're also passing this object because we want to apply this to every single object, and that is why the parameter obj or object is right here. Okay, so those were the 5 must-haves, and now let's go through all of these. So I did not do delegates, generics, or multi-threading, but I did do load data from JSON. So as you can see, I have a JSON file. It's extremely simple, one line. Pool size equals 5,000. So if we go to our object pool, we'll see that right now the pool size is 2,000. But when I press play, it changes to 5,000. So how does this work? Well, in our resources folder, we have a JSON file called info.json, and what we're doing is, let me open the script again. Let's go to our start function really quickly. Right here. So we have a private pool info and a private string. So pool info is just a class, and it's pretty much a public integer, which is how large the pool size will be. And we have a private string called JSON file, and when the game starts, we take that string and we set it to the file, basically where the file is located, so under assets, resources, and then the file name. And then we create a new instance of the class pool info, and with it we use the JSON utility class, we use the from JSON method, and we basically assign the integer pool size to its corresponding variable from the file. And you notice that it has to be exactly the same, and it has to be an integer. So if we change this to 100, and then notice, I can even change, let me change this to just a random number, 654. I press play, and then it should go right to 100. So now it's at 100. Let me do it again. Press play, it just got changed to 100. So this is pretty much proving that it's loading data from the JSON file. Now, I also loaded assets from the resources folder, and that was with the scriptable object and the JSON file. So as you can see, we are actually not with the JSON file. we are using it with the scriptable object. As you can see down here, we call load from resources, which is our custom method. And when we go to our custom method, we see that resources.load path. So we're using the resources method. Now Unity events. As you can see, we have to run an event every time that we click a button, so that we click one of the squares. So that's why I have the event script, which not only implements our custom interface, but it also implements the interface pointer click handler, which is using event data. So pretty much this is going to run every single time that the user clicks a square. So as you can see, we do output sound, audio, and then we press play, and let's let this run. Start, and as you can see, it's emitting a sound every single time. And notice that now the squares are bigger because we actually changed the size 105 and 105. Before, when I first started, the asset was actually 75 by 75, and there were a lot more. There were actually 5,000, whereas now the pool size is 1,000. So we did JSON, assets, events, and now we're doing object pooling. So this whole thing uses object pooling, and the whole point of object pooling is to pretty much optimize instead of instantiating thousands of objects. Rather, instead, we're not instantiating everything as we need it. We instantiate everything that we'll need and then deactivate it, and we just set active to true and false depending on when we need it. So that's why when I press play, you'll notice that this only has one child, but when I press play, there's going to be 1,000 children now, but they're all set active to false. In this way, we're able to easily activate and deactivate them, but the user doesn't know that they exist yet. Like, to the user's thought pattern, they would think that, oh, it actually doesn't exist because it's not on the screen and it's not showing. But really, it is on the screen, it's just deactivated. And we are able to do this by creating our pool, and we create a temporary game object, and we get the component, change it to a random color, put it in the correct folder, set the position, and then we add it to our pool. So now we also have link, and we do use this for, I have these filters, filter R above 128, filter G above 128, and filter B above 128. So if we notice, I can actually enable all of these buttons, and when I press play, let me just mute the audio so I can talk over it. When I press play, there should be buttons on here. When I press start, you'll notice if I do show G above 128, it only shows the green ones above 128. And if I say show blue above 128, it's only going to show blue. And if I say show R, it's only going to show R. And obviously this I can win easily because I can just click anywhere. And this actually proves it, which I just realized, that I can click every single one of these and then I'm going to win. So this is almost like a cheat code in a way. So what this is doing is we create a list and we do from item in the pool. So the pool is from the object pool. And we say where the item, the component image, and as you can see, every single one of these game objects has an image, and it's taking the RGB values of this. And what we consider red is when any red value or R value in the RGB spectrum is above 0.5 or 128. So when we filter G, B, or R, it's just taking that respected R, G, or B value, and if it's greater than 0.5, then it puts it in the list. And then what we do is with our new list that's filtered, we deactivate the pool and then instantly activate only the green, red, or blue, depending on which one we want. So that is link, and then custom editor scripting. So that's 1, 2, 3, 4, 5, 6. So this is the 6th extra one. So I actually did do custom editor scripting, and let me set it up really quickly. So I was able to simulate the object pooling. So let me just deactivate all of these really quickly and set the alpha to 1. So here's our screen. And you'll notice that on the object pool, we have a simulate object pool and clear screen. So if I clear screen, nothing happens because it's already clear. But if I simulate the object pool, well, now I just created 654. And you'll notice that this doesn't read from the JSON file. And this is on purpose due to the fact that if we're simulating in the editor, we would want to use our custom size that we specified right here. And to get rid of it, we just press clear. And you'll notice that the pool size is now 0. So if we simulate 654, if we simulate again, now the size is larger, so we need to clear the whole thing. And this is just able to be used because when we simulate, we're able to see, just out of curiosity, what the RGB values are. This is just for internal testing to make sure that it's properly outputting the pool exactly how we want it. And then we press clear. Okay, so that just about covers it. Those were all of the features that I used in this final project. I hope that you enjoyed this presentation, and thanks for watching.